Chapter 3 Data Representation. This chapter explores how we represent and store the various kinds of data a computer manages. The first, we have data in computers. Data is a basic value or facts, whereas information is data that has been organized and/or processed in a way that is useful in solving some kind of problems. And without data, computers will be useless. In data in computers, we have analog and digital data, and the second is binary representation. In analog and digital data, we have analog signal and digital signal. Analog signal is a continuous representation. And the second, digital data, is a discrete representation, which is breaking the information up into separate elements. And here is the differences between analog and digital signal. Analog signal is continuous flow, and digital signal only have high and low. In binary representation, one bit can represent either 0 or 1. To represent more than two things, we need multiple bits. For example, 2 bits, which can represent 4 things. For combination of 0 and 1 can made from 2 bits, 0, 0, 0, 1, 1, 0, and 1, 1. Next, the second part of data representation, we have representing numeric data. In representing numeric data, we have representing negative values and representing real numbers. In representing negative values, we have signed magnitude representation. In the traditional decimal system, a sign plus or minus is placed before a number's value, although the positive sign is often assumed. The sign represents the ordering and the digits represent the magnitude of the number. A classic value looks something like this, in which a negative sign means that the number is to the left of 0 and the positive number is to the right of 0. Next, we have fixed-sized numbers, where we can represent numbers as just integer values, where half of them represent negative numbers. The third one, we have 2's complement. 2's complement is the most common method of representing signed integers on computers. Usually, the easiest way to calculate 2 complement is to invert the bits and add 1. And the last one, we have number overflow. Overflow occurs when the value that we compute cannot fit into the number of bits we have allocated for the result. Next, representing real numbers. In computing, we can call all non-integer values that can be represented real values. The third part of data representation, we have representing text. The first, we have ASCII character set. Second, the Unicode character. Third, text compression. Let's have a look in ASCII character set. ASCII stands for American Standard Code for Information Interchange. The ASCII character set originally used 7 bits to represent each character, allowing for 128 unique characters. The Unicode character set is the extended version of the ASCII character set, provides 256 characters, which is enough for English but not enough for international use. Text compression. Alphabetic information, as we know as text, is a fundamental type of data. Therefore, it is important that we find ways to store and transmit text efficiently between one computer and another. And here is 3 types of text compression. First, keyword encoding, replacing a frequently used word with a single character. Second, round length encoding, replacing a long series of a repeated character with a count of the repetition. Third, Huffman encoding, using a variable length binary string to represent a character so that frequently used characters have short quotes. For example, suppose we use the following Huffman encoding to represent a few characters A, E, L, O, R, B, D. Then, the word doorbell will be encoded in binary as this. The fourth part of data representation, we have representing audio data. Audio formats. Over the past few years, several formats for audio data have become popular, including this. Next, the MP3 audio format. MP3 is short of MPEG-2 audio layer 3 file. The fifth part of data representation, we have representing image and graphics. First, representing color, which in a computer, color is often expressed as an RGB value, which is using three primary values to make colors. Second, digitized image and graphics. Digitizing a picture is the act of representing it as a collection of individual dots called pixels. And each pixel is composed of a single color. The number of pixels used to represent a picture is called the resolution. In digitized image and graphics, we have raster graphic format, which the storage of image information on a pixel by pixel basis. Also, vector graphics is another technique for representing images. A vector graphic format describes an image in terms of lines and geometric shapes. As we can see from this image, we can see the differences. The last part of data representation, we have representing video. Video information is one of the most complex types of information to capture, compress, and still get a result that makes sense to the human eyes. Video codecs. Codec stands for compressor, decompressor. A video codec refers to the method used to shrink the size of a movie so that it can be played on a computer or over a network. That's all for Chapter 3 Data Representation. Thank you.